Hey guys, it's Vince. Today I'm going to discuss with you stepper motors and how to pick out the correct stepper motor for your desired application. I get messaged consistently, at least 5 to 10 times a day, of how to pick out the proper stepper motor. What do I recommend as the proper stepper motor? And honestly, there's just, after going online, and I've realized this for quite some time, and I'm trying to catch up with videos. Um, as I go through and I research information, there is a lot of misinformation, a lot of rocket science type theory that is just theory, and unfortunately, theory in CNC is just that until we apply mechanical properties to it, and then you find out that theory usually is not always applicable. So what I've tried to do is in this video is basically cover all of the details of how to pick your stepper using the simplest of terms and just using practical knowledge and mostly common sense. I mean, it's mostly common sense, guys. So I'm going to jump right in. I'm going to show you exactly where I began with. Right here is a chart that was designed from this website to describe one of their steppers. You guys are probably familiar with that website. And this stepper that they're using as the example is a 420 ounce inch NEMA 23, and they're using a 48 volt power supply. Okay, that's all we really need to know. Now, some of you might be saying, why is he using a chart from another website? First of all, I don't like redundantly producing information when it's already out there. I would rather discuss it and explain it in a format that I think is missing online. And secondly, I'd like to cover in detail that stepper motors in general are all the same, regardless of the torque they produce, regardless of the stature of mounting, whether it be NEMA 23, 34, 42. All of the statistics of stepper motors are virtually the same. So it's totally applicable to any stepper motor, this chart, and that's why I'm using it. So what you're seeing here, again, if we just look at this real basic format, for those of you who don't know, the slower you run your steppers, the more torque they produce. So they're a perfect candidate for using for CNC because most machining is done at much slower RPMs for precision. Makes sense? As we turn our RPMs up for rapid movements, which is simply the machine moving from place to place on the table, unloaded, just basically lifting the spindle or whatever cutting tool you're using and just basically relocating to the table, you always want to have a rapid that is as quick as possible and as smooth as possible so that you can get your job done as quickly as possible. Now, that being said, rapids are more leaning towards tables that are larger. And the larger the table is, I would say 4 foot by 8 foot and above is where rapids really become more of an issue because, again, you have a table that you're trying to machine on, and maybe that piece of material you're working with is the size of the table, and it can take it can extend your amount of machining time if you're not covering that distance to change a machining location in a short amount of time. You want to keep it as fast as possible, of course, with accuracy, and that's where, again, your rapid movements would come into play. Now, I have guys with 60/40 CNCs or 30/20 or 30/40s, all basically the Chinese chassis, and rapid movements on those chassis really doesn't matter, and I'll explain why. Because realistically, that chassis is only at most maybe 26 inches in width. I think most of them are 24. So realistically, you're covering that chassis even at a moderate RPM of, let's say, 480, 600. You're covering it very, very quickly. I mean, it's a matter of seconds, half a second, second and a half, you're across the table. So it's not nearly as critical as when you start going into those larger base chassis. Now, that being said, if you're a guy who's looking at using a smaller chassis like the Chinese-based chassis, the 60/40, 30/20, 30/40, you definitely want to pick the appropriate motor for the substrate you're using. Okay, I can tell you right now a 60/40 chassis is easily capable of doing aluminum. With the proper spindle, it can even do steel. Okay, it will work fine for that. The big thing there is your feed rate, of course. Those are variables. And, of course, the amount of torque produced by the steppers. Okay, if you're running harder substrates, I would always go with a larger stepper motor because more stress is put on that stepper. So just keep that in mind. If you're running 2.2 kil spindle, first of all, the spindle itself weighs about 14 pounds. So the Z-axis, of course, is always being used, and you'd always want to use a large stepper based upon, again, the weight of the spindle. Now that being said, you know, if you're dealing with a chassis where the chassis itself is supporting all of the weight of the actual substrate you're machining, your steppers are definitely going to be affected because they're carrying that weight. However, if the chassis is not supporting any of the weight, it's a little different variable, because then they're not being loaded as much other than with the feed rates you're using to actually machine the substrate. So what you want to do here is use an educated guess. Now, my educated guess in all the years I've been doing this, I can tell you right now on most steppers, a 200 ounce, 150 to 200 ounce, I like 200 ounce, just easy number to remember. 200 ounces above what you require usually works well. Okay, and why I say 200 ounces is by the time you get to any feed rate in this area, you're still going to have excess torque available that you're not bleeding into the absolute bare minimum or getting close to that stall ratio. So think in those terms. You know, when you see these 60-40 CNCs from China, I can tell you right now they typically come with stock motors that are probably 180 ounce inches, henceforth 300 ounce is your best friend. If you're doing aluminum with that chassis, I recommend going, again, the largest spindle you can afford, preferably the 2.2 if you really want to cut it like butter. And I would definitely go with a 600 ounce stepper on the Z. And then I would go with either a 300 or a 600 ounce, depending upon what feed rates you're looking for. If the price is no object, go 600 ounce. If price is an object, 300 ounce will work. Okay, your feed rates will be a little lower. That's about the only difference. Other than that, that's where you go with. If you're dealing with a larger scale table, if you're dealing with those 4 foot by 8 foot and above, then I would say no less than 600 ounce. If you go 300 ounce, as long as the chassis is not supporting the weight of the substrate, meaning your mechanicals are, all your mechanics are not supporting the raw material you're working with. If the steppers are actually supporting the weight of the raw materials you're trying to cut, then 600 ounce is definitely the way to go. If however, you're looking at a table that's that large, like a plasma system, where typical plasma tables just have the actual table themselves that actually just lets usually the metal substrate lay upon it, and then the mechanics are totally different and supported by, you know, rack and pinion or whichever type of mechanics they use. However, the steppers are not supporting the weight of the substrate, you're fine using 300 ounce steppers. Okay, I was actually over a woman's house this weekend, a client of mine, and we ran her table. We were at 300 ounce inches on her plasma, and it was a 4 foot by 8 foot table, and it ran fine on 300 ounce inches, because again, the table was supporting all the weight and the mechanics were not supporting any of the actual material. So you're fine doing that. And again, a plasma doesn't have the kind of weight associated on the Z-axis of carrying a spindle. So take that into consideration. It's all of what you're building. If you're building a plasma system, you're going at that size table, then I would definitely say, is your mechanics supporting the actual weight of the material you're machining? If you're making a table where the X and Y axis are actually supporting, you know, whatever metal you're putting on there to machine, of course you're going to need a larger stepper. If you're not, you can go with a 300 ounce stepper. Now, would it pay for you to buy a larger stepper? Honestly, that's all dependent on the individual. Will it work? I always get asked that. Will it work with a larger stepper? Of course it'll work with a larger stepper. Is it going to make a lot of difference? Well, again, on a plasma system, certainly not. On a CNC, where you might be using harder, tougher substrates like aluminum, and again, you're dealing with more torque of usually guys that are dealing with aluminum or tougher substrates are looking at working with you know, a 2.2 kil spindle that puts out that kind of horsepower, 4 horsepower. You really then are looking at getting more out of it with the larger actual steppers. So think about it in terms of that. Think about it in terms of what you're going to be doing, what applications you're going to be doing. And when I say, you know, always think in terms of the greatest amount of machining you plan on doing. When I say the greatest amount, I mean the toughest load you're looking at machining. If you're looking at machining at the toughest load, aluminum, then you already know anything you use beneath aluminum in the hardness, you're going to cut like butter. Okay, so again, stepper motors, do you need 600 ounce to mill wood? Not usually. I mean, I have yet to see that kind of torque be required to do wood engraving and stuff like that. But if you plan on doing, I have a lot of guys that do crossover machining where it's, today it's wood, tomorrow may be aluminum. I'm doing 1/4 inch aluminum, and then tomorrow I'm doing, 3/8 plywood. Okay, then your best friend, again, would be a 600 ounce stepper, because if you're looking for optimal speed along with optimal torque, that will give you the biggest range. If you're looking at it just, getting into CNC and really looking at, I have the option to mill aluminum. I don't do it that often. I stick with wood. I stick with acrylic. I stick with carbon. 300 ounce, you're going to be your best friend. So again, budget is everything. Always think of your budget. Always think of, I can always buy more if I need it later. Think of primarily what you're going to be using it for. And for my guys out there who are entrepreneurs and starting out, always think less is more. Don't overbuy unless you absolutely have to, because if the machine is not paying for itself, and quickly paying for itself, you're just falling into debt. The best time to get into a business, of course, we know, is, to be in as little debt as possible. Preferably you guys that are getting involved in this can pay the machine off virtually a couple jobs, you'll pay the machine off. That's what you're looking at doing. So overall, that's the lowdown. And again, what's interesting here, again, this is a 420 ounce stepper. He also has a breakdown using a 960 ounce stepper. And another thing to point out here, a lot of guys think, well, me jumping this kind of torque is where you're really going to get, more bang for your buck, because you're going to have more bleed through. Well, the interesting thing is, with a higher torque stepper means that your mechanics gearing can be a little different, because you could use the more torque at a higher geared ratio to give you more speed, so you never have to run at this RPM. Because if you look here, what's interesting, you have 141 ounce inches on this motor, and you come over here, and on a 420 ounce inch motor, you only got 101. So for all of that difference in price, and for all of that difference when you're dealing with a 960 compared to a 420, which is literally over double rating of that motor, you're only getting 40 ounces difference, 41 ounces difference at the same RPM. So the thing here is, and this is where this gets kind of confusing, is this motor's optimal sweet spot would be somewhere probably around the 600 to produce the amount of torque with a higher pitched lead screw to give you more speed. That's another way the torque can come into play. So instead, you see here at a 60, 120, 240 RPM, he's producing the most amount of torque, because again, these are his machining speeds of RPM. When he comes over here to the 600, 720, you're still at about 340. At 480 or 425, which would be probably his sweet spot, as far as then selecting the lead screw with the higher pitch, so that he can actually, the gearing would be right on the money to make it actually accelerate faster. He's utilizing that torque for more speed. Okay, think of your car's transmission. It's the same thing. I mean, your speed there is all going to be dictated by your torque, and again, that's what we're looking at here. So overall, it's a very, very simple process. The larger the table, and especially the larger the table that's supporting a heavy substrate, and when I say supporting, I mean that's actually on the mechanicals. If you have a heavy substrate that's resting upon your chassis, and your chassis is now supporting all of the weight of that substrate and moving all of the weight of that substrate, you need stronger stepper motors, especially if you're looking at, again, higher feed rates when it comes to rapids. If, however, your chassis is not supporting all your mechanics, where the steppers are located to move the axis, is not supporting all of the weight of that substrate, you don't require that. Because again, if it's just the table holding the substrate and the chassis is moving back and forth and they're totally disconnected from the chassis weight, they're not noticing a different load other than moving the actual spindle or cutting tool. Okay, now the Z-axis on a router is different, of course, we know, because it's holding the spindle. Plasma cutters have, little torches that don't weigh virtually anything. So again, these are the things to keep in mind as you make your selection. Now, to make it a little more easy, I also found a couple videos, and these are not videos to degrade anybody or to insult anybody, but it's a video. These are videos I picked because I think that there's, once again, they're reflecting misinformation, and I think they're inadvertently doing it, but to a lot of people, they're assuming this is right. Okay, here's a video I found. Again, I don't care who this person is. He's using a G540 and he's reflecting 495 IPM rapid test. Now I'm going to show you something in this video, and we're going to see if you guys can figure it out, because you'll probably see it right away. I'm going to turn the volume down. Watch this table as it moves, and I want you to see how much sway is in this table as he's moving at that rapid. And you'll notice every time this table moves back and forth, it's shaking. Okay? Now that just simply means that whoever's setting this table up, first of all, they're obviously not aware that if you're machining with a speed of a rapid that fast, and you can see that, again, the motor tuning is not set correctly because the table is not smoothly coming to a stop. It's creating so much inertia going back and forth, the chassis itself is swaying. And this is aluminum, guys. I don't want to hear that because I'm using aluminum, I can run the table as fast as I want. It doesn't work that way. I mean, how it really reflects is the fact that, just as we were speaking about, this table, number one, is not even loaded. Okay, there's nothing on this chassis. It looks like he has a spoil board there. We can see that his steppers are not supporting any weight of the substrate. If this table was loaded with a sheet of aluminum, and the steppers were supporting this table, moving it back and forth like basically a what do you call a Y or an X-axis mill, then you would find the stepper motors need to be much stronger. You can see here, it doesn't matter what size stepper he's using here, because the only thing he's actually moving is the gantry, and again, the X and Y movement is really rolling on top of this aluminum, looks like extrusion. But the interesting thing to watch when he stops, you can see the shake in this table. It's immense. Just look at the sway as it goes back and forth. To sit there and post this and show that kind of rapid, when first of all, it's not even accurate because the table itself is not loaded, okay? In the sense of, if this was a supported table where the table is supporting a substrate, it's much more critical to do a test like rapids when it's actually formulated loaded. He does not have a spindle here loaded, so again, the stress on the Z is not accurate yet. Until this table is calibrated with all of the stresses that would be in practical machining, he is simply going with variables, and that is not accurate. This is not an accurate accrual of what you can expect on all chassis. So I'm guaranteeing you, just by watching the sway here, he's going to drop this down about 200 IPM before this table will even smoothen out, especially as you see the back and forth motion with the sway. If he went to machine with that kind of motion at all, especially with the herky-jerky start and stop, a lot of that, again, has to do with the way he set the motor velocity and the acceleration inside Mach 3. He would have problems, okay, especially with accuracy. So, and if you read it right here, but it shook the table. I had it on, so I slowed it down a bit for this video. So what's interesting is, this is actually humorous. I ran it at 600 IPM. And then he says it shook the table, so he slowed it down a bit. Well, he shook the table at 600, so he slowed it down to 495. If he thinks that's acceptable, that's absolutely frightening. I mean, that's absolutely not acceptable. And again, that's where, we've got to look at these things. And if you guys are looking at setting your table up right, this is frightening right here. What you're seeing with this, you would not be happy with the results you would get with this. Okay? Now, as we start going, and again, we've talked about what tables I recommend. I'm not going to get into all that, but this is why I recommend a nice sturdy frame, because this is the kind of crap that you will see. And again, be realistic of what you're using with the components you're using. This is, like I said, it's frightening to see, and to claim that as being acceptable. I can't imagine, out of 10,738 views, how many guys have looked back and go, yeah, that's acceptable, I saw it in the video. Okay, so I want to just clarify what you guys are seeing. The other aspect, and I'm going to show you now what is acceptable. Okay, this video is a full-scale CNC. And again, why I'm showing you full scale is let's not forget what we're doing here. Full scale and your CNC, whether it be small, large, whether it's a Bridgeport, whatever it may be, a Haas, Tormach, it's all basically the same. The scale of the machine may be different. The principle is exactly the same. This is interesting because this is a part this machine is going with. If you look here at the product weight, the material weight, this is massive. This is full-scale industrial type machining. If you come over here and you watch this, and I'm just going to go through, look at the speed and the cut this machine is doing. Look at how smooth it's moving. Look, it's got its proper coolant again. A lot of guys now that are using aluminum are, of course, using coolant. It's flowing over the end mill. That's a proper machining method, okay? That's when you see a machine run like this, that's when you can be assured you're going to get a finished product that you can easily not only resell, but I mean the quality of what you're doing with your machine is just impeccable. Now when we fast forward this, I just want to show you now, even on the, oops, see, I fast forwarded too much, sorry. We'll skip this video. I just want to show you exactly what I'm talking about. Here we go. Okay. Now, as this machine accelerates and stops, the things to pay attention to, you can see right there that cutting rate is actually very, very high for a part that big. If you think about it, when this machine changes directions and stops, look at how smooth that is. It's virtually linear, so that your tolerances stay and maintain throughout the machining process. That's essentially what you're going to. I don't care if you're machining wood, aluminum, whatever substrate you're looking for, this is the type of machining you're looking for, where it can change directions, be smooth, be concise, and be linear. You don't want herky-jerky motions, you want smooth. And if you look at that part, you can see exactly where they're going with that. I mean, that's exactly what you're looking at, and again, you see the actual cut speed, that's what matters, is the accuracy. Once again, we have another poor example, and I'll show you right here. Another one, he's using 80-20 extrusion. He's claiming he's running at 1,000 IPM. Again, table's unloaded, no spindle mounted. He's just watching the table go back and forth. Here we go. I turn the volume off. You'll get to see it move. And you can see right here, let's look at the size of this table. This is probably, give or take, I'm going to guess 24 inches, maybe 30 inches at the max. Actually, I'm right here. I didn't even read that. It's actually 33 by 30. Okay, and he's talking about running 1,000 inches per minute. Remember, guys, the faster you run your rapids, the more stress you put on your machine. And on top of that, a table of this size, even if he ran this table at 700, 500 inches a minute, he would still clear this chassis in a matter of seconds. So when you watch somebody do this, and he's so proud of it, let's see, we'll go through and, you know, there he goes. He's reflecting that he's running at 1,000 inches a minute. You guys have seen tons of videos like this. Again, I think this video would be 10 times more impressive to show this machine cutting with a variance of 1,000, 2,000th of an inch on a part he made. That to me is what true CNC machining is about, and most of you understand that. You know, and if you do your research, you're going to figure it out very quickly that rapids on a table of this size is kind of a joke. When you start, like I said, getting into those full-scale size routers, that's when rapids become critical. So again, stepper motor size becomes critical. But hopefully with this video now, you have a very good assessment as far as what to look for when you're picking your steppers. And honestly, what to look for with your machine, because in these two videos right here that you've seen, it's going to really, it hopefully, you know, reiterates the point that smaller chassis, it's not about feed rates. It's really about precision. You know, I mean, those smaller chassis, you're going to get the feed rates. If you're running 48 volts, those motors are going to spin. Okay, the big thing there is how smooth the chassis is and how precise everything is when you machine it. Once you get to the larger chassis, it's the exact same principle. It's just a matter of you having the rapid you need to support clearing this amount of area to get from point A to point B the fastest so it can start machining again. Usually guys that are using those large tables, of course they're using it for business, because the guys with a hobby typically are not going to drop the kind of money that it takes to actually facilitate owning one. So just keep that in mind, and once again, hopefully it's been explained to you in a way now that's easier. Again, if you do have any questions, don't be afraid to ask. But overall, Stepper motors are nothing to be afraid of. I work with my guys exclusively. If you guys have, any questions, if you're in doubt, you can always order the 300 ounce I have, test it on your table, and worst case scenario, if you ever said, hey, I'm ready to go 600 ounce, or I think I tried the 300 and I need the 600, send them back. I'll give you the 600. Pay the difference, you get 600 ounce. There's no, again, we're trying to get you set up optimally. We're not looking at, whatever that takes. If that takes me helping you or going over exact dimensions of what you're dealing with, we'll do it. That's the difference. That's a service I offer. So hopefully this video has been helpful. I hope you guys do review the full scale machining video, because again, videos like this are probably the most informative, because when you watch these type of machines run, it's such a smooth, it's almost artistic how the machine actually runs. It's so smooth, and that's what we really should be focusing on with even the smaller grade machines, because whether you're doing it for hobby or if you're just leading a hobby to a profitable business, so to speak, you're definitely going to want to have a machine that's set up and you can rely on, and that's the best way to go through. Always use what's already been done, especially with rapid type machining in the full scale world. I mean, you can see how their machines work. You can replicate it with yours as close as possible, and you'll be very, very happy with the results. So once again, my name is Vince. I'm on eDealers Direct on eBay. If you have any questions, don't be afraid to ask. Again, if you want to talk, we can schedule a time to talk. I'm not afraid to do that. Again, there's no secrets. There's no, hiding behind the internet. Whatever you need, I'm here to help. Let me know. Any videos you guys want to see, don't be afraid to send me some ideas. Thank you. Take care.